Fraud is a major issue that banks all over the world face today. And a common type of fraud is fraud in credit card applications. Banks spend millions of dollars as well as thousands of hours trying to solve this issue. But what if I told you we could design a computer algorithm which would help combat this issue at a fraction of the time as well as a fraction of the cost? And that's where deep learning comes into play. Deep learning is essentially a type of machine learning, which is a subset of artificial intelligence. In deep learning, algorithms are modeled after the human brain. And so, leveraging deep learning, I was able to create a self-organizing map, which is a type of artificial neural network. This self-organizing map is able to return a list ranked based on how likely customers are to have committed fraud in their credit card applications. So, let's check out the
So we
code
can
to
start
see how
off
it
by
works.
taking a look at our dataset. Our dataset contains a variety of categorical data, most of which is unlabeled since we're using an unsupervised learning model. And so the model itself is going to have to find patterns and correlations between this data, which is unlabeled. And so we have 690 different customers that we have data for, and we have 16 independent variables or 16 categories of data which we can use to train our model. Technically, we only have 14, since one of them being our customer ID isn't very relevant in improving the accuracy of our model, and one of our independent variables is really our dependent variable, which tells us if a customer has committed fraud or not. So let's take a look at the code. Our first part is basically identifying frauds with our self-organizing map. So we import our libraries, then we import the data set, and then we separate our data set into dependent and independent variables so that we can use our independent variables to train our self-organizing map. Then we do a bit of feature scaling where we normalize our independent variables to values between 0 and 1 so that can be accepted by our ANN, which we'll create. And then we can train our self-organizing map by initializing a variety of parameters, and then we randomly initialize its weights and train our sum on independent variables. Next, we visualize our results by printing our self-organizing map in the Python console. So up here, we've specified a few parameters on how we want to print it. So the x-axis has to have a length of 10, and so does the y-axis, for example. And then we just continue on here, visualizing the results by continuing to print out our self-organizing map onto the Python console. Next, we get our winning node for each customer, which is basically represented by the lightest shades of these squares. And then we plot a winning marker on a winning node depending on if the customer gets approved or not. And then we get a list of customers that have fraudulent activity, which is in our variable explorer. And then we get the coordinates of our outlying winning nodes, and then we do a bit of inverse normalization. And so for now, for part 2, where we create a matrix of features and create our dependent variable. So we can create our matrix of features or our set of independent variables through this simple line of code. And then we create our dependent variable by first initializing a vector of zeros. And then if a customer ID is found in a list of fraud, since we actually don't know the name of the customer itself, we're going to change its value from 0 to 1. Then once again, we're going to do a bit of feature scaling. Now comes to the part where we actually make our ANN so our model can train itself based off of our data. So that we start to import our Keras libraries and packages. Then we initialize the ANN. And so for our ANN, we're only going to have one hidden layer and one input layer and obviously an output layer. So our input layer is basically going to consist of 15 nodes, and our hidden layer is going to consist of 2 nodes. And the activation function we're going to use for both our input layers as well as our hidden layers is going to be the rectifier function. And then, like usual, we're going to use our dropout regularization method, which is going to stop potential overfitting so that the model itself doesn't train itself too well on their data. Then we import our second layer, and then finally our output layer, which consists of 1 node and which we use the sigmoid activation function for, since it works well with binary outputs. Now we compile our ANN using our binary cross entropy loss function, and then we fed our ANN to our training set, and then we predict each probability of customer being a fraud so that we can create a ranked list of how likely each one is to committing fraud. And then we create a 2D array of our customer IDs and predicted probabilities, which is essentially just creating our list, and then we sort customers from least likely to most likely to being a fraud.
Hope you guys enjoy the video. Check out the description below for an article that I wrote on the basics of self-organizing machines, as well as a GitHub repository that contains the code to my self-organizing map. Don't forget to follow me on LinkedIn and check out my personal website in the description below to learn about more of the cool projects that I've made. Anyways, see you guys next time.